Hello and welcome. In this video, we're going to take a look at a little topic that involves a bit of integration and a bit of supply and demand at the same time. When we look at supply and demand, we can find equilibrium, and then with that in mind, we can take a look at what some of the areas on that graph might represent, and that's where we get consumers and producers surplus. So let's start off with reviewing a little bit about supply and demand and equilibrium. Now remember, we have a supply curve and a demand curve, and the convention here is to have price on the vertical axis and quantity on the horizontal axis. That's not necessarily intuitive because oftentimes we think about having price influence the quantity that is purchased. However, this quantity does make it nice with the fact that quantity is on the horizontal axis, and that's typically how we would like to have our revenue, cost, and profit functions as well. Now remember, when we have equilibrium price, which we will denote with P with a little bar over the top, then at that point we have the same quantity being supplied and demanded. So you can see that that price here is this horizontal dashed line, and you have the equilibrium point right there. This is the intersection of these two curves, and they intersect at X bar. In order to find X bar, then you just simply have to set these two functions equal to each other and solve for X bar. And with that value, we can plug it back in and find the equilibrium price. If we have higher prices, then there will be potentially more suppliers who wish to produce that good and will have additional supply. Higher price will indicate higher profit. But at that particular price, we'll also see fewer consumers wishing to purchase the product, which means less demand. At a lower price, we have the opposite situation. Fewer suppliers and producers are going to want to produce this product, but because it has now been easier to buy, people with other preferences may switch to purchasing this product, or people with lower income may be able to purchase this product, and we'll see more demand. Now, what we're going to be taking a look at is what some of these regions here over in this left-hand side might actually imply. Let's start off with consumer surplus and give an idea about what this region here actually indicates at the top left-hand corner. Now, it might help to zoom this graph in a little bit. And we're going to be taking a look at this top left-hand region where you see that the price is a little bit higher than the equilibrium price. Now, at any point in time, you can see that there is some demand even at higher prices. And these points here will indicate that there are consumers willing to pay that particular price to still purchase this product. Now, if the price of the product is in fact at equilibrium, then you can see that the person here at this particular dot is going to feel like they're getting some amount of savings. They value the product higher than the current price of it. So they would feel like they are getting maybe some sort of savings or some good deal on that particular product. There are some people who would buy this product practically regardless of price. You can see that at the far left-hand side, there's quite a difference between the price they're willing to pay and the price they have to pay. Now, if you can imagine that each of those consumers is paying less than they would be willing to pay, imagine that we took all of those perceived sort of savings together and added them up. That would give us this shaded region here. And we call that shaded region the consumer's surplus. We can denote that as CS for short. So this is a measurement of the total combined perceived savings of consumers who would be willing to pay more than the equilibrium price. And now you see that this is simply just an integration problem. If this is not a linear function and it is some kind of curve, the only way to really accurately get that region is to look at an integral. And we have two functions that we will be taking a look at the area between. One of these functions is the demand curve itself, which forms the upper boundary of that shaded region. And the lower boundary is a horizontal line, where simply P is equal to P bar. This gives us a nice little formula for the consumer surplus. We will be integrating the region below the demand function and above the function P bar. And we will only be integrating from x equals 0 to x equals x bar. Now, we can also simplify that a little bit. Because P bar is simply a constant value, we can apply the constant function rule to that particular term, as well as the difference rule for integrating two functions that are being subtracted. The antiderivative of this minus P bar will be minus P bar x. And we need to evaluate that term from 0 to x bar. Well, plugging in x bar and plugging in 0, that tells us that consumer surplus is the definite integral from 0 to x bar of our demand function minus the product of equilibrium price and equilibrium quantity. Hopefully that makes sense, because it's really just the area underneath the entire demand function from 0 to x bar. We are subtracting that little rectangle, which has a height of P bar and a width of x bar, to get the triangular region. And there we have the formula for consumer surplus. Now let's take a look at producer surplus, which is fairly similar, but we'll be taking a look at a different region. Now, with producer surplus, of course, we're going to be focusing on production and the supply of a good, and we'll be taking a look at what happens when the price is set to be a little lower than our equilibrium price. You can see in this region that there are still producers willing to produce a product even though it is being sold at a lower price. There will be maybe fewer producers, or producers may be willing to only produce a smaller quantity, but we still end up with some supply even though price has dropped. Well, for each of these particular suppliers, they would be willing to make a certain quantity, and they can now sell it for a higher price. So it might feel like they have some additional amount of profit at that particular equilibrium price. And at the far end of this particular region, you can see that there are producers who would be willing to produce this product for substantially less than it is actually being sold. And you can see that for each of these producers, that they are getting some perceived gain. They are all feeling like they are getting a really good deal out of selling this product at that equilibrium price. If we were to add all of those sort of perceived gains together, we would get the area of this particular region. And we refer to that region as the producer's surplus, or PS for short. Again, this is now an integration problem. We need to find the area above the supply curve, but below the equilibrium price. So the formula for producer surplus is fairly similar. We're going to be taking a look at the area below the equilibrium price, which is a constant, and the area above the supply curve. And we'll be looking for the area between x equals 0 and x equal to x bar, the equilibrium quantity. And of course, we can simplify that in really the same sort of way. Since P bar is just a constant, this can be simplified to equilibrium price times equilibrium quantity minus the definite integral from 0 to x bar of our supply curve. And again, hopefully that kind of makes sense. We can think about this as being the area of this entire rectangle, which is going to be having a height of P hat and a width of x bar, and then subtracting the area under the supply curve to just get that region that we're looking at in the sort of the little triangle that we have shaded now. Well, let's take a look at an example of a supply and demand function and see if we can calculate producer's surplus and consumer surplus. In this example, let's suppose that the price of a product, lowercase p in dollars, is determined by supply and demand functions, which are given below here. We've got our blue function for demand, which is 300 minus 0.001 x squared. And you can double check using the derivative that that is always decreasing for any values of x greater than 0. And we've got our supply function, 0.0005 x squared plus 0.06 x plus 84. Again, you can check that that is always sloping upwards using the derivative, and you'll see that it is a positive derivative whenever x is greater than 0. Here, x is in thousands of units, but price, again, is just in dollars. Now, before we take a look at the consumer's and producer's surplus, let's take a look and find the equilibrium quantity and price. We can do that by setting demand function and supply function equal to each other. When we set the two functions equal to each other, then we can solve for that equilibrium quantity. And luckily, this is just a quadratic equal to another quadratic, So we can collect all the terms on one side of this equation and set the other side equal to 0. From there, we can use the quadratic formula. When we solve the quadratic equation, we're going to get two answers. However, one of them is going to be negative. We're only going to be taking a look at a positive quantity, and we should get x bar is equal to 360. Now let's not forget that that is also in thousands of units, not just in single units. Once we've got that equilibrium quantity, then we can plug that x bar 360 back into either demand or supply. Might not even be a bad idea to plug it back into both and make sure they come out with the same price. Now price is in dollars. We should end up getting our equilibrium price equal to $170.40. Now that we have our equilibrium quantity and equilibrium price, now we can start taking a look at consumers and producers surplus. And while we're at it, why don't we take a look at the total surplus, which is the sum of the consumers and producers surplus. We'll start off by using the formula for consumer surplus. A definite integral from 0 to equilibrium quantity of the demand function minus the equilibrium price times equilibrium quantity. And we'll start off with the definite integral from 0 to 360. Luckily, this is just a polynomial, so we can apply the power rule. And the antiderivative will be 300x minus 0.001 over 3x cubed. We'll have to evaluate that from x equals 0 to x equals 360, and then subtract the product of 360 and 170.4, which is 61,344. Luckily, when we evaluate at 0, we'll end up with 0 here at the beginning, so we really only need to plug in 360. And this gives 92,448 minus 61,344 for a total consumer surplus of 31,104. Now, be careful of the units here. Consumer surplus is an area. And if you remember about the area here, on our price, we have dollars, which is a vertical axis, and along the horizontal axis, we have thousands of units. So every unit of area here is actually equivalent to $1,000, which means that our consumer surplus here is in thousands of dollars. Now let's compute the producer's surplus, which is a very, very similar calculation. In fact, we already know what the product of P bar and X bar is. We'll start with the formula for producer's surplus and plug in our supply function as well as our equilibrium quantity and equilibrium price. And once we've plugged those in, we luckily already know that this product of 360 and 170.4 is 61,344. Applying the power rule to that particular supply function, and then we'll have to evaluate that from 0 to 360. And don't forget that minus sign. We have to subtract the entire result of that definite integral. After evaluating and subtracting, this gives a producer surplus of 19,440. And again, the units of producer surplus are in $1,000. And now, let's find the total surplus. We are simply just going to add those two values together. Total surplus is 50,544, again, in $1,000. Now, this number, total surplus, if you take a look back at the picture here, you can see that this is actually the two shaded regions combined, and it is really just the area below the demand function, but above the supply curve. So that's what that total area there is. So you can see that this is a very quick application of integral calculus and areas between curves regarding supply and demand. Now what we can do with this is a little experiment by seeing what happens when we impose some kind of tax on the production of this product. If we were to impose a tax on production, then that's going to start raising prices for production. Let's see what happens to these surpluses when we add a particular percentage value of tax onto it. If we go back to our original equilibrium diagram with supply and demand, and think about what happens if we were to impose some kind of tax on that supply curve. Well, whatever price the suppliers are willing to set that product at is then going to have tax added onto it. We might imagine that that might be a fixed percentage, for instance. That's going to take every point on the supply curve and raise it by a certain percentage. So now we have another curve, and this is going to be the supply curve with tax. Why don't we say that this price is S sub t of x? It's just the supply curve's price with additional tax added onto it. Well, that's going to shift our equilibrium, unfortunately. You can see now that it's not really an equilibrium of the price set by the supplier and the price set by the consumer. The new equilibrium price and quantity is actually also now determined because of tax. The equilibrium quantity is now going to be the intersection of the supply plus tax and the consumer's demand curve. This is where we see that that price has gone up because of supply, and so demand has dropped slightly. That's a lower equilibrium quantity than before, but a higher equilibrium price than originally. This will take the consumer surplus and it will shrink that area. You can see the blue shaded region that is below the demand curve, but above the equilibrium price is now a little smaller than it used to be. But what about the producer's surplus? That's a little bit more interesting. The producers, unfortunately, don't get any of that tax money. They are actually now selling less than they used to be, and the only price that they see is the portion that lies on the red function. So to take a look at the producer's surplus, we actually need to find out what the price is for the suppliers at that particular quantity. And once we find out what price the producers are actually getting in revenue from that product, then we can find the area underneath that price and above the supply curve. And you can see that that area has also shrunk. So you might be asking the question now, what about all that additional area? Well, the difference between the price that the suppliers are receiving in revenue and the price that the consumers are paying for that product, that particular portion of the price is being collected by the government in tax. And so for the quantity being sold multiplied by the difference between the prices of what the consumer is paying and what is being given to the producers, this rectangular region is our tax region. We have this new additional region. Consumer surplus is smaller than before, producer surplus is smaller than before, and now we have an entire region of some kind of revenue for the government. But even those three regions added together is no longer quite as large as the combined region of the previous consumer's producer's surplus. We have this little tiny triangle where it doesn't seem like any consumers are happy, it doesn't seem like any producers are happy, and none of that revenue is actually going to taxes anymore. This missing region is called deadweight loss. It's essentially saying that this particular economy, for whatever this product is no longer as efficient as it once was. There's a third party that is now getting a little bit happier. That would be the government. They're getting some tax. But overall, this particular product has no longer quite as efficient of an economy anymore. Now, if we wanted to, we could take a look at that previous example and just imagine what's going to happen if we were to impose something like a 10% tax on the production of that product. Now, part of the good news is that the demand curve and the supply curve don't change at all. However, we do have to calculate a brand new curve, which is the supply curve plus 10% tax. That can easily be done by taking all of the terms of the supply curve and multiplying them by 1.10. Multiplying 0.005 by 1.1, 0.06 by 1.1, and 84 by 1.1 will get the coefficients of our supply curve with tax. And now we're going to have to take a look at a brand new equilibrium quantity. We'll have to do that by setting our demand function equal to the supply curve plus tax. Solving the resulting equation, unfortunately, doesn't give quite as nice of a value this time. But we should be finding that the equilibrium quantity has decreased since prices have gone up. Throwing out our negative answer, the only positive value for x is 345.3 approximately. If we want to use 3 decimal places, then this will at least give us to the nearest whole unit when we take a look at X bar, because it is in thousands of units. As for equilibrium price, we have to be a little bit careful about this. The equilibrium price that we typically look at is when we take this particular quantity and plug it back into the demand function to find out what price consumers are paying. This gives us a price of roughly $180.77. But remember, that is just the price that consumers are paying. That is this particular top intersection point of the supply with tax curve, our green curve, and the blue demand curve. But we're also going to need to take a look at what price is actually being collected by the producers themselves that isn't going to tax. And that is what happens when we take this particular equilibrium quantity and plug it into the supply curve. So let's call this P bar demand, and we'll take a look at P bar supply. Plugging the same quantity into our supply curve, we see that they are only collecting $164.33 approximately. And it should be no surprise that $180.77 is the exact value of $164.33 plus 10% tax. Now that we've got the equilibrium quantity as well as these two prices, we can see what happens to the consumers and producers' surpluses. We can also see what portion is being collected from tax and see how much is lost from the original total surplus due to deadweight loss. Using the formula for consumers and producers' surpluses, we can use the same equilibrium quantity, 345.300 thousand units, but we have to be careful about which price we're using. The equilibrium price for the demand function, or for the consumers, is $180.77, but the equilibrium price for the supply curve is $164.33. And I'll leave it as an exercise to you to go ahead and integrate this and plug in those values. We'll have the same antiderivatives as before, but we'll be plugging in a slightly different equilibrium quantity. And you should see that the consumers and producers' surpluses have both shrunk from what they were originally. And sure enough, we can see that both those numbers are reduced. We have our consumer surplus as $27,447, that's in thousands of dollars, and our producer surplus as $17,299. That's also in thousands of dollars. Remember, you can convert those to millions if you like. How about the other regions that we haven't talked about yet? We'll take a look back at this picture and we can calculate tax pretty quickly without using integration, because that region is always a perfect rectangle. You can see it's simply just the difference between the price paid by the consumers and the price received in revenue from the producers multiplied by the width of that rectangle, which is X bar. Pretty quick to calculate that, and we don't need the integral. We'll take the difference between those two prices and multiply by our equilibrium quantity. This will also be in thousands of dollars. And once again, I'll round to the nearest $1,000. This is $5,677,000. I'm rounding to the nearest $1,000 because these prices and quantities were also rounded, and I can probably only really give a relatively accurate value for these three values to the nearest $1,000. Now, what happens if I add these three things together? It's not going to be the same as the total surplus that we had previously. Previously, our total surplus was $50,544,000. If we add our current consumers' surplus, producers' surplus, and tax together, now we only get $50,423,000. If we subtract those two values, we get the deadweight loss. In this case, the deadweight loss is $121,000. Remember, on our picture from before, that is the small little triangle that isn't really making anybody happy in this economy. The producers aren't very happy because they're getting a smaller quantity and a lower price. The consumers aren't as happy because the price has gone even higher due to taxes. And so there's fewer of the product being consumed. Of course, the government's happy. They're getting some amount of tax when they weren't before. But unfortunately, because quantity is reduced, there's always going to be a small piece of the pie that nobody is going to be happy with anymore. So that kind of gives you an illustration about equilibrium, price, quantity, supply and demand, and also kind of what motivates consumers and producers to have that particular desired price. Consumer surplus, producer surplus are these kind of interesting concepts where we take a look at those areas to represent how happy consumers are and how happy suppliers are with the given equilibrium. Well, again, that's really just an application of areas between curves, so it's kind of nice to see where we might be able to apply that topic. We'll have some other applications in the future, so stay tuned, and thanks for watching, and I'll see you in the next video.